Good afternoon. Today I'm going to show you how to get started in PCB layout using MultiSim and Ultiboard. You should have already downloaded these packages and installed your license. You've played with MultiSim before, so you should be able to open it up, and when you do, it should look something like this. Now, to get started in a schematic, what you do with MultiSim is you go File, New, bring up a blank schematic, and here's a schematic. This one is 8.5 by 11, so it's a fairly small schematic. In the options, you can change the sheet properties to make it bigger or smaller. So here the workspace is 8.5 by 11, which is a nice size. It prints well on a regular printer. It faxes well. As soon as you get into an 11 by 17, which can hold more information, it gets harder to print it because not everyone has an 11 by 17 printer sitting around. But 8.5 by 11, we'll do a schematic on that today. Once you've opened your schematic, once you've got it ready to go, you usually start by placing components. Now, when you go to place components, what MultiSim does is it usually offers you a part from the master database. Now, the master database is a collection of parts. They're kind of like a starter set that National Instruments gives you to get going in your schematic and layout. But there's a couple of different parts. Parts are handled differently depending on what kind of part it is and what kind of features it has. So not all parts are created equal. Once you've gone to the master database, the parts are separated into groups. So here's like all families. So the top level is top level groups are sources, basic diodes, transistors, probably about 10 or 15 different groups or categories that breaks the parts down into. So what I'm going to do is I'm going to start off by placing a connector. And I've already kind of picked this one before. So here's a connector that comes with the master database. And this particular connector is like a 171.009.113R001. And just the number itself kind of implies that this is a very specific connector. So it's a DB9, it's a 9-pin serial port connector with this part number, and that just seems to be very specific. And if you go into DigiKey and you search for this part number, what DigiKey will give you is that it's a D sub connector. If you search for kind of like up to 113, so it's a D sub connector. This is an R911, this is an R001, 3111. It's basically this part and only this part, and made by Norcomp Inc. So that is when you're placing that in MultiSim, you are placing this part, unique, one of a kind. So that's the first kind of part that you can place in MultiSim, is a specific one-of-a-kind part. Now the next part that I'm going to put into here, I'm going to go into the logic family. So let's go back to, let's say, CMOS, and let's go with a 4-volt CMOS. Let me place a 74 HC14. Now, even here, you can see if I go down to like 74 HC14, there's a D type and an N type. Now, I'm going to place a D type for now, and then it comes up with an A. I'll explain this in a second. Well, that, a 74 HC14D, if I go into DigiKey and I search for those parts, what I come up with is one of these. So this is a surface mount part. Looks like it's 14-pin surface mount. It's it is available from several manufacturers. So it's not one of a kind. It's a kind of like a 2x4. Well, is it spruce? Is it fir? As long as it's 2 inches by 4 inches, it'll fit our space. So this is a little bit more generic part. And the D suffix on it, so the D on it, imply that it's surface mount. If I had decided to place a 74HC14N, then it would be a through-hole part. And I would be getting this package. So obviously when you're picking the part out of the database, you have to really make sure that you're getting the right part, because you may be putting these on the circuit board, but if you don't communicate that properly to everyone in the company, purchasing may be bringing these in. And if you're building this to go into tractors that is starting a production line on August 31st, and you bring in the wrong part, you're not going to be very popular. So this kind of part is kind of like when we place a 74HC14, this is kind of like a little bit more generic part. It's available from several vendors and in several different package types. Now, when you look down here on MultiSim, you can see that here I'm picking a D part, and what it does is it comes up and it tells you right over here, it says that the D part is a DO14 package. So this tells you what the footprint is right here. If I pick the N part is an NO16 package. So this is a different package. So right here, these packages basically tell you what the package is. You can still get that from several different manufacturers to fit on that footprint. The other thing that happens is that when I go to place, let's say, a 74HC14, and I say OK, it presents me with, well, you can put down a new part, or you can put down U1, B, C, D, E, F. So the HC14, let's just take a look at the HC14 again. So I'm going to bring up the HC14. This is the data sheet for the HC14. It's a hex Schmidt trigger inverter. Package looks like this. So this is the surface mount package, and you can get that. So this is the D suffix, is this package. The DT suffix is a small surface mount one. Well, inside the HC14, there is actually 6 inverters, all separate, input output, and they give you the pins here. So this is A1, Y1. So here's A1, Y1. So this one here is basically between these 2 pins. The second one, third one, fourth one. And then pin 7 is allocated to ground. Pin 14 is allocated to VCC. So basically the power for this chip comes in on 14 and the ground is on pin 7. And this is pretty standard on logic chips, that the opposite corners are power and ground. And inside are 6 packages. So when I go to place a second one of these, I can place a new one, which is now the A package. It is the A package from U2. So this is U2A. So that would be the second chip, the first inverter in the second chip. And then if I go to place another one, so here I'll place another one of these. It says, do you want to do it in U1, U2? And now I could, let's say I could say this one here, I want to place U1B. So this is the second inverter in U1. And that would be this one here, which was between pins 3 and 4. So that would be this one here. C would be this one. D would be this one, E and F. So when you're placing this, an inverter or a logic chip as a schematic, it's a multi-part symbol. These 2 components here, U1A, U1B, are both placed in the same package and they're separate inverters in the same package. U to A is now an entirely different new package. The other thing that you may notice about U1A, this inverter here, is although I've placed the inverter, there's no power pins visible when I place this part. It doesn't tell me to hook up the power. Now this is what's using a standard logic chip will use what's called hidden pins. If I right click on this guy here and I bring up the properties and I look at the pins, you can see that there are what's called hidden pins. Power and ground, if we put power and ground on everything in a schematic, we'd have wires running all over the place, running over here, running over there, and it just makes the schematic easier to read if I don't show every single line. So power and ground, they're pretty much going to 5 volts. That's automatic, and by default it needs to go to 5 volts. So they will usually hide that from you so that it makes the schematic easier to read. So these are, and I can turn on, the other thing I can do with this is if I bring up the properties of this part, I can look at the labels and I can look at the display. By default, it uses the sheet visibility, kind of like you decide what the sheet does. But I can also go in here and I can show the package pin names. So this is pin 1 and pin 2 on the final package when you do the layout. And then this guy here, if I turn on his guys here, show package pin names, this is pins 3 and 4 on the symbol. If I plunk down U1A, U1F, I wouldn't have pins 7 and 14. Those are allocated to power and ground automatically. So this is an example of a specific part that has a symbol and a footprint associated with it. This is an example of a more generic part done in a multi-part schematic that has several different types of, you could buy it from several different manufacturers. This particular one's only available from one guy. This is available from several people in this footprint and different footprints. So that's another type of symbol. And then there's another thing that I could place, which is a basic part such as a resistor. So I'm going to place a 1 k ohm resistor here under this guy, and then I'm also going to place a basic part, which is a capacitor, and I'll place a 1 microfarad capacitor. If you want to rotate something, just go Control R and it'll rotate it around like so. So I'm going to make a little oscillator here. That goes there, that goes there. You can see as I'm putting it down, it's putting numbers beside this, which is actually the net name. That's because I've got it visible in the sheet properties. So if I go up into sheet visibility, see I'm showing all the net names. As you make wire connections, it will assign a name to those connections. It'll give those, now the name just happens to be, that one is named net number 2, but there's no numeric value associated with a net name. It's just an ASCII character string that it uses. So I'm going to hide them all for now, like so, to get rid of the net names. Then I'm going to plunk this thing here. Now, the resistors and the capacitors, when you place those down, see, these are more generic again. So if I go into DigiKey and I do a search for a 1 k ohm resistor, what you'll find, we'll just type that in, 1 k ohm resistor. What you'll find is it comes back with over 100,000 surface mount versions, 13,500 through holes, there's resistor networks, there's potentiometers. There's probably 250,000 different types of 1K ohm resistors. Clearly this is too many to be in the master database in MultiSim. So what MultiSim does is it kind of treats it more like a generic part where you pick the value and you pick the footprint and then it'll give you that part. It's not a specific manufacturer, it's very generic. So when you go in to place a component, such as a 1K ohm resistor, so here's resistor 1K, what it does is over here, it gives you the option of picking a footprint for that part. So the default is no package, and then there is all kinds of different packages that you can pick. So if I pick, here's one here, 1600 by 900, that's probably like 1.6 inches by 0.5 inches. Sorry, that's not a 900. So I can pick that. Okay. And then it puts it down. You can see as soon as it puts it down, it's blue, while before it was black. So a black component does not have a footprint associated with it, and a blue one does. This is if you've got the default color scheme. So this has a footprint associated with it. This does not. If you place the part, you can go back into the properties and you can edit the package. And one of the things that you can do is you can select it from the database so you can pick whatever kind of package you want. So here I'm looking at the database, and we start off the database has every possible footprint ever made, including 3 pins, connectors. We need to narrow that down a little bit. A resistor, I want a 2-pin through-hole resistor. So in order to narrow it down a bit, what I would do is I bring up the filters and I can add a row and I can say, well, let's make it how many pins, pin count equals 2. So now that will filter out a whole bunch of things. I want SMT or TH. I want SMT to be equal to TH. I want a through-hole component. And then I can say, okay. So it's eliminated a bunch of those packages, and now it's showing me a whole bunch of different things. However, the caps are still in there. The cap footprints are still in there because they're 2-pin through-hole. I might be able to narrow it down a little bit more. Here's something that says RES. So these are probably resistors. It has RES in the name. So let me add a row. We'll say package contains RES. So now I have the resistor footprints in different sizes, and I can say that this is 1500 by 900, I think, by 250. Old eyes. So I can pick that one. Comes up down here that's what the part that's been picked. Okay, so now I've changed this to one of the parts in the footprints in the database. It's not a real part. It's not a specific manufacturer's part or part number. It's a 1K ohm resistor with a footprint this size. And I can do that with the caps. Bring up the properties, edit the package, select from database. I'm just going to go with this one here. That is a electrolytic capacitor, surface mount. You can see the positive sign on one end indicates where the positive terminal is. So now that has a package, and I'll just delete this one. So there we go. I had a couple of parts, kind of putting a schematic together. Another kind of part that I can place from the database, so let's go back to the sources, is I can place parts or objects that have no footprint associated with them. So for example, on a power source, I can put in the ground symbol, and if I put in the ground, I can connect that to ground. So there's a ground terminal connection, but a ground doesn't really have a part on a board. It's one of the traces, but it's not a separate physical part that I would buy. It comes with the circuit board. So, and then another one that I would place on the circuit board as a power source might be VCC. So this is VCC, and I'm going to bring that in here, and I'm going to connect that to pin 1 of the connector, and then I'm going to connect, I'm going to copy and paste the ground here. So there's ground. So here's how I'm bringing ground and power into my circuit board, is through these pins on the connector. And I'm going to have this input coming over to here. So here's the connector, that goes over to there. I create a little oscillator circuit. And I'm going to have the output go here. And then I'll pretty it up a little bit here, grabbing wires, dragging them. So here's a more or less complete schematic that I can turn into a circuit board. I have a connector, power and ground comes into the connector, and then there's also a signal that comes in to this oscillator circuit. Here's an oscillator, and it inverts it, and then we feed that back out. This chip U1A gets its 5 volts from this point here. The hidden pin is connected to 5 volts, the hidden power pin, and the hidden ground pin is connected to this point. So I didn't have to connect those, they're connected automatically. So here I've got more or less I've got a finished schematic. Next thing I'm going to show you is how we transfer this information over to the layout package.